Hello, good day. Once again, you're welcome back. Let's take a look at this integral. I is equal to integral sine open bracket ln x or the x. Here, let's look for an appropriate techniques that needed to uh, be used, in resolving this the integral. Here, you can see that this sine x is a function of is also a function of another function which is ln x. So it is necessary that we're going to use substitutions here first of all to uh, transform ln x so that to know the appropriate techniques to be used. Okay. Yes. Now we say let g is equal to ln x, so that this integral becomes sine g dx as equation 1 here. Now, we also know that ln s can also be written as log x to base e, which is a natural logarithm, so that we will now find an appropriate uh, expression for the x from g is equal to ln x. So from definition of logarithm, s can also be written as um, exponential g. That means s is equal to e raised to the power of g. Okay, this form equation 2. So here we differentiate both sides so that this becomes ds, and note that the derivative of exponential g is also exponential g. So this becomes the x dg is equal to exponential g, and so that ds is equal to multiplying both sides by ds, this become exponential g dg. So in place of the s, the appropriate expression for the s is exponential g dg. Okay, substituting it in this expression, it become integral sine g exponential g dg. So in it, because we said that I is equal to this, so we say the integral exponential g sine g dg is equal to I. Here we can see clearly the method or the techniques to be used. Here we're going to use integration by parts. Here we have a product, exponential g and sine g as the two functions. So here we both are differentiable and both are also integrable. But here we look at the one that is more differentiable. So the one that is easily differentiable or is immediately differentiable is exponential g. So that become our v. And our du here is equals to sine g dg. So to obtain the v, so we differentiate the v with respect to exponential g, and this becomes the v over the g is equal to exponential g, so that the v is equal to exponential g dg. Then to obtain u, we integrate both sides of the u, and the integral on the right hand side, integral of sine g here is minus cos g. Okay, here we know that the formula for integration by part is vu minus integral of u dv. Okay, so v du is equal to vu minus integral of u dv. So substituting here, we have that v is exponential g and u is minus cos g. Then minus integral u is cos g, and dv is exponential g dg. Okay. Then next here, this minus here, we take care of this minus. We factor it out. Minus times minus become plus, so that the expression become exponential g cos g plus integral exponential g cos g dg. So here, from this part here, you see that this part is also carrying an integral sign. So that means we still have to apply the same approach. Okay, as we did earlier. Okay, so the integral of exponential g cos g dg, here v again is exponential g and the u is cos g dg. Then the integral of the u is equals to if we integrate cos g, the answer is sine g. Okay, so our dv is always exponential g dg. If substituting again, we have uv or vu minus integral of u dv. It becomes exponential sine g minus integral of exponential exponential g sine g dg. And if you look at this part here, it's just exactly the function. It's exactly the function we obtain. You know, it's exactly this function. Okay, and we said that let this is equals to this. So here I'm referring to this part of this function. If you look at this function, they are the same. Okay, so and we say I is equals to this. So in place of this function, we will replace it with I. So here on the right hand side, I is equals to exponential g cos g plus exponential g sine g minus I. Okay, this part of this function, this is part of the integral here. The part of this integral here. Okay, part of this integral here. The first part of it is exponential g sine g. So imputing it here, become from the previous one we did exponential minus exponential g cos g plus exponential g sine g minus this integral, and this integral is I. Okay, so minus I, and where this I has to move to the right hand side to become plus I. So I plus I to give us 2I is equals to minus exponential g cos g plus exponential g sine g. So that by dividing both sides of this equation by 2, the result become exponential g divided by 2 open bracket. This cos exponential g is a shouting factor here. So here this become, because here is plus, so the positive sign is brought out first, minus cos g close bracket. But initially we said that g is equals to ln x, so that I is equals to exponential ln x over 2 into sine ln x minus cos ln x close bracket plus an arbitrary constant. We also recall that exponential ln x is the same thing as exponential log x to base e. But you remember from law of logarithm, if a power, the power and the base of a logarithm are the same, the answer here is just that particular logarithm, which is x. So here this expression turn out to be the whole of this place turn out to be x. So that I is equals to x over 2 open bracket sine ln x close bracket minus cos s ln s close bracket plus an arbitrary constants. Okay, this is how to resolve this equation. If you find the video interesting, please help me subscribe to my YouTube channel and also share it through your social media platform. Have a nice time. See you in my next virtual class.